This conference will now be recorded.
There are kind of two types of databases that you would have already known. That is RDBMS, and there is NoSQL database. So RDBMS are nothing but your relational database service or management systems, where you have defined a schema, right? You have a relationship between two tables, and your table are already defined. For example, if there is a employee table, you already have defined a schema saying, okay, employee ID, employee name, salary, city, right? Age, everything you would have already defined. The schema is defined. So each and every table inside that particular um, database there will be some relation to that, right? So you will have a primary key as your employee ID, and in another table you will have employee ID and salary, and you will kind of do a primary key foreign key relationship. So there are some kind of relationship between those tables. They are all called relational database services. So the traditional database that we are using, like MySQL, Oracle, or MS SQL, MariaDB, Postgres, they're all relational databases. Similarly, we have something called NoSQL database, so which is now getting more popularity. NoSQL database is like just exactly opposite to our RDBMS, where you need not have a, wherever you don't have a strict rigid schema, right? It's not needed. It dynamically gets changed. Your columns get changed dynamically. Then you can use NoSQL database. And we will talk about one such database in AWS, which is called DynamoDB, which we will see at the end when it comes there. But for now, we'll focus on RDS. So RDS stands for Relational Database Service. It's a managed DB service for DB use and SQL as your query language, right? You can use your structured query language to access those databases and read the data and do all those processing. So it allows you to create databases in the cloud that are managed by AWS. So there is a difference here. RDS service is basically a managed service, which means that most of the things are taken care for you by AWS, and you don't have to worry about certain upgrades and stuff. So currently, these are all the databases that are engines that are supported right now. We have Postgres, MySQL, MariaDB, Oracle, Microsoft SQL Server, and there is another server called Aurora, which is nothing but your AWS proprietary database, which basically uses your Postgres and MySQL engines in the background, right? So this is their proprietary database, which is not available as open source or free tier. Now, you can do one more thing also, right? You can create an EC2 and you can install MySQL there, right? You can do that also, right? That is also possible. So now, what is the advantage that we have, right? Like using a managed service or on EC2. If you're having a managed service, the OS level patching will be taken care by AWS. All continuous backups and specific timestamp point in time restored. They're called point in time restores. Those are all taken care by AWS. You get some monitoring dashboards. You also get some read replicas for improved read performance. We'll talk about read replicas more. And you can also set up a multi-AZ setup for your disaster recovery in case your primary goes down. Because see, for any company, the data is very important. The application is not very important, right? Application you can build application, but you cannot get that, you cannot build the data. So you accumulate the data over time. So the data is very, very important. So whenever we talk about data or database, we immediately talk about disaster recoveries and backups, right? Then you can also provide your maintenance window for all your upgrades and stuff. And you also have a scaling capability to do both vertical and horizontal scaling. Since it's a managed service, you cannot SSH into that particular instance wherever it is hosted. But on the other hand, if you go ahead and go to an EC2, create an EC2 machine, log into that machine and go to the internet, download MySQL, still you can download, you can configure, you can do everything. But again, if that is the mode of style that you're going to follow, there will be a lot of admin overhead for you. You have to manage your patching, you have to manage your upgrades, you have to make sure the maintenance windows are there, and your performance will depend upon the instance DB instance type that you are in. Suppose if you are using T2 micro, you will have only limited performance. When your database grows, your performance will go down. So in order to do that, you need to keep doing vertical scaling, horizontal scaling, and all those things by yourself. So basically, it is not recommended to use your EC2 and have your own database installed in EC2, but it's always better to go for your managed service. So if you are going to a customer and giving a solution, and your customer is more adamant on having EC2 on the database on EC2, you need to list out all the advantages and disadvantages and the overheads and the additional cost that you will incur if you have on your EC2 versus the using the managed service. So that is how you need to convince your customer. The customer will not know, right? Customer will always be in the mood of like your on-prem, right? So they only know about on-prem. They are moving to cloud. So it is cloud architect's responsibility to make sure that the client understands exactly how they will benefit from using this managed service rather than going and installing our own database into EC2. Okay. So for the RDS, any RDS, you will get up to 5 read replicas. What are read replicas, right? So in any application, right? Suppose I have a big application where people do a lot of writes on that application, and also they do a lot of reads, like they take very frequently, they take reports, they download some file, they do some read operations, right? So many read intensive operations. And there may be a situation where your manager might say, oh, hey, the analytics and data science team needs to do some analysis on our data. Can you create a user and give it to them? What we normally do, we create a user to them in the same database, give it to them, and they will go and read the data. And what will happen, it will be in the same database. Our customers will keep writing, and these applications will keep on reading, and your database can go slow. The performance can go slow, or even it can go down depending upon the intensive how intense your application is reading and writing, right? It depends on that. So with the read replicas, what this AWS provides you is you can create up to 5 read replicas for all these databases. So in your application, wherever there is a read intensive, you can change that endpoint to the read replica. So what will happen is you will read the data only from those read replicas. Still, your master database will take the writes, and that will not suffer any load. So how will the data be transferred from your master to read replica? It will happen asynchronously. That means when you insert a data into one table in master database, the data will be available in read replica within few seconds, not immediately, within few seconds. So that is why it is called asynchronous. It is not happening at the same time. Okay, but replication is asynchronous, but still you will have the full data. So the reads are eventually consistent. They are not strongly consistent, they are eventually consistent. So suppose if you are writing in a table called say Suresh, right? And after a few seconds, when you use the read replica, they will see Suresh. And suppose immediately you don't update that to Ganesh, right? The read replica, the application that reads from read replica will get only Suresh unless it gets updated by asynchronously by from the master to change the name from Suresh to Ganesh. So it may take 1 or 2 seconds. In between that 1 or 2 seconds, you will get the old record that is called eventual consistent. Okay, so your replication is asynchronous, so the reads are your eventual consistent. Replicas can be promoted to their own DB. Suppose if there is some issue with the master, one of the read replicas can be promoted to the master as well, and it can take the writes. But only thing you need to make sure, our application needs to change the connection string wherever we are reading the data, and wherever we are writing the data, we need to change the connection string to point to the master. So this is how it happens, right? This is your application. This is your application. Your application has so many functionalities and features, and so many people, your customers keep submitting data to the database. You go and read right from database, and also you create a read replica for this. What will happen? Suppose there are any, say, a very big report they want to take, right? It's only a read operation, because reports are just read operations. They don't store anything in the database for retrieving a report. So what you do, if you don't have a read replica, again you need to pass all the queries to your master database and say, for example, you have millions and millions of rows, right? This will suffer, and your writes from the normal functionality will keep either failing or it will be very slow. In order to avoid that, we have to change the our endpoint to point to this read replica. So whenever we create a read replica, then you get a new endpoint, and that endpoint should be there wherever you are trying to read a read feature in your application. And the master database will behave normally. Just use it for writes and small reads, not for read intensive. So suppose your manager comes and says that there is a something going on and we need to have your data to do some AI and data science, and they want to bring in some insights to the organization. They will ask you to give them this one. Don't worry about that. Just give them this endpoint URL from one of the read replica, so that will not affect your master database, right? So your customers still can write and read from this master database without any performance issues. Okay, that is where we have this read replica. So in RDS, you get up to 5 read replicas created for you. Okay, so this is on the read replica. Next is on the multi-AZ. If you enable this RDS multi-AZ feature, this is specifically for disaster recovery. That means you have a primary database and it creates a standby database in a different availability zone. Keep that in mind. It will go in a different availability zone. Suppose your master database is in US East 1A availability zone. The standby might be created in B, C, D, or E, but not in A. Okay, it will be an entirely different availability zone because it is for disaster recovery. So that's a primary, that's a standby. So the data moves from primary to standby using synchronous replication, which means as you keep updating your master database, the standby database also will get updated with the data, and there will be only one DNS name. So you don't have to change anything. Whenever there is a failover, automatic failover will happen, and there will be only one endpoint, and it will be used for both primary and standby. You cannot access your standby directly. Okay, you cannot access your standby directly. So when these failovers will happen, whenever there is some problem with our availability zone, loss of network, instance, storage failure, all those can trigger a failover. In that case, if you have enabled this multi-AZ, automatically the database will be switched from primary to standby. There is no any type of manual intervention in the application that you need to do if you enable this. And again, this multi-AZ is used only for disaster recovery. It is not used for scaling or doing some other operations, right? So it's purely for disaster recovery. Okay, just keep in mind here, you need to go and update the connection string in your applications to leverage your read replicas, whereas here there is only one DNS name. There is no any manual intervention. If something happens to the primary, it automatically gets failed over to the secondary standby instance. So now in this case, if you are enabling this multi-AZ, you have your application, you have a primary database at your availability zone A, and if you enable this, automatically a standby database is created in another availability zone. I'll just put it for reference as B. It can be anything, but not in the same availability zone. And you can still keep reading, writing to this one. There will be only one DNS name or the endpoint URL, which you will just need to configure in your application for all the reads and writes. So what you can do, you can enable read replicas and this disaster recovery. So what will happen? You will have one whole thing for your master, and wherever is read, please change it to a read replica. So this operation, the data moving from master to the standby, is synchronous. So when you put Suresh, immediately Suresh will be here. Update to Ganesh, it immediately update will be available here. So that is synchronous. So that happens immediately. So at any point of time, both these databases will have the same data. Okay, but you cannot access your standby instances directly. You can only access your through this DNS name. We don't know at what point of time where it is pointing to. If it is failed over, it might get into standby. If it is normal operation, it might get into the normal master. We will see all these things. Okay. Okay. Any questions here, guys, so far? So just know the difference between read replicas and disaster recovery multi-AZ, right? It's very important. So as I told you, whenever we talk about data, the immediately next thing should come to your mind is backup, because that without the data, the company cannot do anything. You will have a lot of sensitive information, your customers' information. If your application is completely lost, someone can help you to write the application, but if the data are lost, nobody can regain the data. So backups are very, very important. Backups are automatically enabled in your RDS, relational database service. Automated backup is nothing but it will take a daily full snapshot of your database. It will capture all the transaction logs in real time. And what will happen is you have the ability to restore to any point in time, right? Say you can say you restore the data. Suppose something has happened and you want to restore the data, you can say go and restore till yesterday, right? 10 p.m. It will take all the data and come back and give you up to the 10 p.m. And you can set your own retention date. So the backups can be retained for 7 days, right? And minimum is 7 days, maximum is 35 days. Okay. So when you put 7 days, what will happen? You take a backup on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. When you take the backup on Sunday, it's the 7th backup. So that backup and all the 7 backups are available. Now you take the next backup on next Monday, the 8th backup. What will happen? The first backup, whatever was retained, that will be removed, and always only 7 will be remaining there, right? So that is the retention. So you can say how many days of backup you need to retain. You can have up to maximum 35 days, up to a month. Again, please note, all these backups are stored indirectly into S3 buckets, which will get charged indirectly. So you need to make sure you come up with this number appropriately, depending upon your situation, your client's requirement, and your company's backup retention policy. Okay, these are all automatic backups. There is something called DB snapshot. What will happen if I need to do something manually, right? So you can go and manually trigger. You can trigger this and take a snapshot whenever you want. And the retention of this particular backup that you're taking manually, it can be as long as you want, because it does not be done by the system. Again, please keep a note. All these storages are there, getting all the backups and everything, gets all those files get stored in your S3. Eventually you may need to end up paying cost in the S3. So please be very careful what you're doing with this snapshots and backups and stuff, right? So backups are automatic, snapshots are manual. Okay. Next, again, since we're talking about data, we need to talk about encryption. So encryption at rest capability is with AWS KMS, AES 256 encryption, just like our S3 bucket. What we saw, we can go to KMS service, create a new key, and you can encrypt your data at rest. So SSL certificate to encrypt data in flight. So you can pass your data through HTTPS. To enforce HTTPS, if it is a PostgreSQL, then you need to enable this parameter RDS.force_SSL equal to 1 in your RDS console. We will go there and see. And if you are using a MySQL, then you need to go and put this query there. Like say, grant usage on start to MySQL user at require SSL. Again, when you are enabling SSL secure socket layer, then you need to have a trust certificate installed. You can download it from the AWS Certificate Manager ACM, or from external you can import it into ACM and use that for your certificate also. Provide SSL login, and also not only just installing the SSL will solve this issue. When you're trying to connect, you have to make sure you pass the SSL options also, right? So this is just a encryption for your database or data at rest. Specifically data at rest, data in the flight will be used using SSL. If you want to enable, these are all the steps for these engines. Then security, this is encryption, this is security. So always keep in mind your databases are usually deployed within a private subnet, not in a public one. Okay, so you should never ever have your database in public subnet. It should be always in private subnet only. Nobody should be able to access, I mean, nobody means your customers, end customers should never access your database directly. Always the database should be accessed only through the application or from the admin using some client tool, but you cannot do it from other places. So it should always be done from the application. So security works by leveraging a security group, just like our EC2 instance. So it can control who can communicate with the RDS. IAM policies will help you control who can manage your RDS. So when you are creating an IAM user, you can specifically say, okay, this particular user can have full privilege on RDS, or he has only the read-only access on the RDS, right? Right now we have created IAM user with all administrator permission, so we are able to see everything. But if you wanted to try this out, you can create a user, restrict on RDS, then go back to RDS service and check, log in as that user, go back to that service and check if that policy works fine, right? You can also use a traditional username password to log into a database, just like we used to have the master database username password, right? We can use that also. IAM users can now be used to do. You can use IAM users also for MySQL, Aurora, everything they have already enabled. This is on the security. Okay, so always it should be on the private subnet. Okay, now let's go back to the console and just see what is that RDS and how can we deploy one MySQL and go through some of the steps and see how we can connect and how we can do. For this demo, since I don't have any application, right? I told you this should not be in the public subnet. Right now, since I don't have any application, I have to show you how to access this database using a database client. I will be launching this in the public mode, but in the real time, we will not be doing it. Okay, just for your information, we will only access through the application. Right now, I don't have any application to go and install and check our database. Okay, so let's go to our console. Log into the console with your IAM user, which has the full administrator access as usual. Please stop me if you have any questions then and there. Please get it clarified. Okay, fine. So either you go to the services and go to the database, click on database. You can see RDS service here, or you can go back here and you can go and select or just type RDS. You will be able to get to that service as well. Manage relational database services. Click on this. Okay, so this is your dashboard where you can see all the details of your database. So let's go try to create a database, right? Let's create a database. As I told you, these are all the engines that are supported by AWS. Amazon Aurora is their proprietary DB, MySQL engine, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. I think most of the databases that we have in our organizations right now, 95 to 98% of them fall within these five: MySQL, MariaDB, Postgres, Oracle, Microsoft SQL Server. There may be some exception to some other databases if they have, but at least majority of the corporations are using this currently. Okay. Now, there are two ways that you can create a database, a template type of thing for you. One is a standard create and there is a EC create. So when you go to the standard create, you go through each and every options and select standard create. EC create will just only enable the ones wherever you need to give some input. Rest everything will be taken as default, but we will not go for that. Otherwise, we will not know what are those parameters and how to give those values. So we'll go for standard create and we will try to create this MySQL database. Okay, you can create any database you want. Go ahead with MySQL. When you select the engine here, okay, you will get the edition and you will also get the version here. Right? If you want to go to previous version, another version, you can go and select on your requirement. Even if you go to MariaDB, right, it again changes for the MariaDB. So if you are aware, you can go ahead and select your correct this one. Right? Since we are just learning, I'm just keeping it as default. Okay, see here Microsoft SQL, all those things that you can do. Let's go to MySQL and let's leave this default. Edition is community edition, and please review this to see if there are any limitations on those versions. What is the limitation on the previous version and all those things, right? So you can go through this and you can find out if it's specifically anything for you is there. You can go and take a look at this. Okay, there are some templates they have provided: production grade template, dev test template, and free tier. Of course, we are going to create in free tier, but if you enable free tier, what will happen? Most of the things will be grayed out or disabled. So what I'm going to do, I'm going to put it in the production grade, so all the options are enabled. We will go through all the options, but before creating, we will change it to the free tier. Okay, so let's start now. So any questions here, guys? So standard create, we are going to go with standard create, and we are going to select the engine as MySQL, and this is the default one. We are going to use the production template to go through the entire attributes that are there, and then we will come back to free tier and create our database. Okay, let's start one by one. So availability and durability, right? See, when you go to free tier, right, this is disabled by default, so you cannot enable multi-AZ DB cluster where we talked about for disaster recovery, right? So if it's a production grade, then you can go do it. So how are we going to do this, right? When we are doing in free tier, this will be disabled. After we create the database, we can go and edit and change this. I don't know, some loophole is there, so we can go and do that ideally. Okay, anyway, let's go with this one. So here, this is where you say your availability and durability. So you have multi-AZ DB cluster. Okay, so it creates a DB cluster with a primary database instance and two readable standby instances in different availability zone. On multi-AZ DB instance, you have, see, DB cluster is different, DB instance is different. DB instances will create only one. When you say multi-AZ, it will create one in the primary AZ, another one in the second AZ. When it's a cluster, there are a group of instances. Okay, there are a group of DB instances. That's a cluster. This is a single, or you want to create a single DB instance, right? Of course, for free tier, all this will be only single instance, so we are not going to select anything here for now. So just know that there is availability and durability. These are the three things that are there. So this is the name of your identifier. How you want your database to be identified. It's not the database name, it is a database identifier. You can say it's a my new SQL DB. This is just a identifier for your database. So where this identifier will be there in the dashboard, if you go, it will just go to the dashboard and go to DB instances, and it will list here the name. The name that is getting listed here only is nothing but your DB identifier. This is nothing to do with your DB schema, nothing, just the name. Okay, so just keep that in mind. Okay. Okay, so we saw availability and this one, and settings. Let's go and put whatever name that we want. Okay, it's up to us. By test SQL DB is the identifier. Okay, now coming back to credentials, this is a master username. By default is admin, so you can change that, whether you want to do a auto generate on this or you want to give your custom password. Let us go and give our custom password, because only I am going to log in now. So this can be kind of a service account you have already created to connect your database. You can give it here, right? So this is the credential section. Give this, whether it is free tier or production grade tier, you need to give this, because without this we cannot log into our application, to your database. Coming to the instance configuration, right? Since I have enabled a production grade, you are seeing everything enabled. So whether you want a standard classes, memory optimized classes, or burstable classes. Now as I told you, even though it is a managed service, behind the scene it is actually created based upon your instance type only. Okay, so you want a memory class or whatever it is, right? So see, they're all very huge systems, and you will have to 8 GB. You need to pay for this one. Now suppose if I select this one, right? So like this one, you want to go for memory optimized as well. This is the all T classes you have, right? Just select something, right? We're not going to create with this, but just select this. Then coming back to the storage, this is just a configuration for your instance type, what type of instance you need. Now, what is the storage, right? So these are all the storage. You have general purpose storage, provisioned with IOPS, magnetic. We saw already this in the EPS when we talked about VPS volumes. It's the same thing. So when you go for general purpose, right, the minimum is 20 gigabytes and you have maximum of 65,536 gigabyte, right? This is minimum. If you go below minimum, it will not allow you. Okay, when you go and create, it will throw an error. So minimum should be 20. If you go for provision, right, provision, the minimum is 100. So what is the difference between general purpose and provision? Whenever you do a provision, this you will get charged for 100 GB, whether you are using it or not, right? Because it is being provisioned specifically for you, right? So that is the reason. So this is the provisioned IOPS that you get. IOPS is nothing but input output per second, how much throughput, how much data transfer speed that you can get, right, with this things, right? That's this one. Let's go for general purpose, keep it on 20. Whether you want to enable storage auto scaling, right? When the storage limit reaches, do you want to increase the storage? You can go and put it here, and you can just put it, say whenever my storage is reaching like 22nd to 22, please go and start creating your auto scaling, right? It will keep adding the storage. So this is for your auto scaling. We will disable this before we create, but just know that there's an auto scaling also, right? As we saw in our deck, auto scaling is there. Next, connectivity, right? This is very important. How are you going to connect your database? So as I told you, all our databases should always be in private subnet. That is why by default it will always be publicly accesses. No, that means RDS will not assign any public IP. There is no public IP, it will be in the private. But for us to actually demonstrate that we are able to connect the database, I have to make it public. And here is the VPC information. If you, in your organization, you will not have default VPC as we saw in the last class when we talked about VPC. So you will have to select your own correct VPC where your application is stored. Select that VPC and it creates a subnet group. Either you can go back and create a subnet group first here and then come back and select here, or you can leave it default, it will create it for you. It's up to you, right? It's up to you. Then for now, let me make it as yes, because I need to access it. And now security group, I told you, right, this entire access is controlled using security group. So what we will do, we will create a new security group and we will give it a name called MySQL DB SG. Okay, so let's go back to that security group after it is created and see what it has created. Okay, so this is on how we will access this, right? Connectivity. Additional configuration, whether you want to use the default port for MySQL it is 3306. Some companies will override this, so you can go and change the port number, whatever you want, right? So as you keep changing the engine, the port numbers will change. If it is Oracle, it is 1521, right? These are all default ports. Okay, you can override it here. Next comes your authentication part. How you want your database to be authenticated. Whether you want to authenticate using password authentication, just username passwords that we gave on the top admin, or you want to use password and IAM database authentication, or you want to use password and Kerberos authentication if you have enabled Kerberos authentication for your company, right? You can do this. So for now, we will go with password authentication and we will use the admin username password, whatever we have given on the top. So this is the type of authentication that we are going to do. Now, go back to the additional configuration here. Here is where you need to give your schema name, where your schema wants to create, where your tables will be created. I simply say my DB is the name of the DB database for my application. Now, there are some DB parameter group and option group that are default created based upon the engine that we select, right? So I have selected MySQL 8.0. So it is by default taking this. If you are a DBA and you know what to do for those tuning parameters you need to change, you can go and create your own parameter group and own option group, and you can select it here. It's up to you. Okay, I'm just leaving this default for now. I'm not a DBA, so I'm not really sure if I change something, what is the impact on that. But this is the place where the DBAs will go and make some fine-tuning stuff for your database. Okay. Now here, you can enable automated backups. So create a point-in-time snapshot of your database. You can enable that. And as I told you, you can set up a retention period. Even though it says from 1 to 35 days, minimum is 7 days. Okay, and maximum is 35 days. So you can put your retention days here. Now, since it's a managed service, this backup will not be taken by you. Since it has been taken automatically, you need to give a backup window. If you don't specify a backup window time, then AWS will think that you did not give the time. It will go and backup whenever it requires, right? Whenever it finds some slot, it will do a backup, which is not correct. That might be your business hours. So you need to go back and choose a backup window, and all time will be in UTC, Universal Time Coordinate. So to set the time, suppose if you are in IST, your system is in IST, then please convert this UTC back to IST and select your time accordingly here. Okay. Say for example, now the time is 9 UTC, right? I say 9 UTC, 9:15 UTC, that is equal to by something, and how much duration I want by data, depending upon the data. Suppose if you think your database backup will take 1 hour, make it 2 hours. So you have some kind of flexibility. Even if something goes wrong, you have 1 hour to backup and recover and stuff, right? Manually. So you can choose this backup window. And any tags that you give, copy that to the snapshot also. Then this is on your backup. Then next is the encryption, as we talked about, right? If you enable the encryption, either you want to use the default encryption, or you can go and create a encryption in the KMS and come and select it here based on that your own key. So this is a managed key. This is a managed by AWS. So if you use this key, you will not have any control over this key like auditing or key rotations and stuff. So if you want to have this one, create your master customer key in your KMS service and you can come and select it here. Okay. Then performance insights. If you turn on this performance insights, what will happen? It will go to the CloudWatch service and it will start collecting the logs there, and it will give you some kind of performance insights of your application, like whether there are any slow running queries and what is happening and all those things, right? And again, for free trial, it is 7 days retention is there. After that, it's 1 month, 2 months, and all those things, at 24 months up to 2 years, and rest of the others will be charged. Okay. Anyway, we are not going to turn on this one, but just wanted to let you know. Okay. Again, read this warning here. Once you set up your KMS key enabled for your performance insights, you can never change. So please be very careful on that. Next is on the monitoring. Enable enhanced monitoring. You can go up to the granular as up to 1 second. By default, it is 60 seconds. You can go up to 1 second, which is near real time, right? Almost real time, 1 second. Okay, you can enable the monitoring. All this monitoring will happen based upon your different processes of threads, use of CPU, and all those things will get logged into your CloudWatch service. So CloudWatch is a service, logging and monitoring service for your AWS. Almost all the services of AWS will leverage CloudWatch service to store their metrics and logs. Okay, so monitoring role, you can select your monitoring role, or it will go and create a role, default role, or you can create a role. See, what is this monitoring role will do? RDS will need to have permission. I told you, right, when two services need to talk to each other, they need to have a role and permission. Without permission, one service cannot talk to another service also. So in AWS, right? So it will create an IAM role, which will allow RDS to access and write to your CloudWatch logs or service, right? So what are the things that you can export in the log, right? These are some of the things that you can do, export in the log. One is the audit log, error log, general log, and slow query log, right? Slow query log. Just give me 1 minute. Okay, so you can enable these logs, and when you go there, suppose if your users are saying that you are reporting, when we try to run some reports, it's taking long time. Go back to the slow query log and check if any of your logs or query is taking more time to execute and get the results back. then your DBS can take a look at this and they can fine tune those SQL queries in order to make it faster, right? So all these logs will help you to do that. Audit logs will basically have all the events that are happening in the database. Error logs, any error logs, general logs, both access logs and error logs, slow query logs will only give you the queries, all the queries that will be logged there. And that again, this will need this linked role, so it will automatically create this role. Okay, very important, maintenance. Since this has been managed by AWS, again the maintenance also is done by them, right? So if you enable this, any auto minor version upgrade of your database will happen. Suppose if you are having SQL, now we are having 8.10, right? Tomorrow they are releasing 8.10.1, then we are allowing AWS to go and do the auto upgrade on that, minor version upgrade. So that is what this enable. Now again, there also we need to make sure we choose the maintenance window. Otherwise, this guy will go keep updating whenever he wants, right? So please make sure you do when you wanted to give a maintenance window, right? So again, your backup window should not coincide with your maintenance window. Both should be different. So this I'll say, okay, I need on Sunday, because I will always let my clients know in advance that there will be Sunday, every Sunday 2 hours there will be some maintenance, right? At 9 o'clock. Okay, see here what's happening. It cannot overlap, right? It cannot overlap. So that is where I'm saying change the date, right? Change the time, change the date. You will have this and say at this time, and what is the duration for your maintenance. If your maintenance normally takes 1 hour, I would always recommend to have at least 2 hours of buffer, so you can let the customer know your database every Sunday at this time will not be available for 3 to 4 hours. You need to say that, right? So you have a recovery time, so you can go see. Even though we say all these are automatic, right? If something happens, we need to jump into a call with AWS, and we may need some time to recover those things, right? So that is where we need to kind of select this maintenance window. Again, just keep in mind your maintenance window and your backup window should not overlap. The timing should not overlap. Both cannot happen at the same time. Because when you are doing maintenance, you cannot take a backup, correct? So that is a logic. Now delete protection, there is one important thing here. As an admin, if you enable this, nobody else other than the admins will be able to delete the database accidentally, right? There are some junior resources who just join, they might not know, they might go and do some deletion. It might be even in dev also, right? They can delete. So it's always better to enable this one. And if you disable this one, then anybody can go and delete the database without any issues if they have the access. Okay, so these are all the things that we have for database, and based upon whatever we have selected in production, this is our estimated monthly cost that we might incur. For the DB instances is $300, and multi-ACC again, you are trying to replicate this, so it is becoming 3,000 plus 3,000, right? It's almost like 3,000 to 3,000 plus 3,000. This is double the amount. Everything will happen in this standby also. So you need to be very careful while you are saying the pricing for DB to your customer, right? So this is where you have the storage cost based upon whatever we have selected now. This is the monthly cost that we will have. Okay. Any questions here before we change to free tier and how this will go off and we'll create the database? Any doubt here? So this is the maintenance section, monitoring section, backup, monitoring, maintenance, and this is your authentication. And again, this is your connectivity, and this is your storage and auto scaling, instance configuration, and this is your settings, and this is your availability and durability. Any questions that you guys have? So while you are thinking about that, let me disable this auto scaling. Let me disable the backup. I'm not going to go for any encryption right now. Okay. Performance insights I'm not going to put. I'm not going to have any type of monitoring now. And maintenance also, I'm not going to have anything maintenance for now. Okay. Now let me go back and change this to free tier. Just see what happens, right? Go to free tier. See, this is grayed out. We have the settings. This will not change. Instance configuration by default will be dbt3.micro. Rest everything is disabled. So this is only allowed for free tier. Okay. Go back down 20. Connectivities will all be there. No issues in that. Additional configuration, password, and you can go here and see this. We have disabled all these things. Now you see, since you are in free tier, like your free tier will apply, right? You will not get the charge now. Let's go and create the database. Creation of database will take 5 minutes, 5 to 8 minutes. Okay. So hit on create database. Okay, see here. This is the name of the database that we gave, my test SQL DB, and this will get created. It is creating your database. While this is creating, we'll just go back to the left navigation and see what other things are available. Once it is created, we will go inside and check what we can do, right? So there is a query editor. You can go and query, but we don't have. Once the database is created, you'll be able to see that. Then any performance insights, if you may have available, you'll get like this performance insights. And DevOps Guru for RDS is nothing but your artificial intelligence powered DevOps Guru. So it will give you some insights on your database and stuff. So when you take a manual snapshots, it will come here, and automated backups will be here. So automated backups will be here. Current region, any replicated, any retained region. We have retained for 7 days, it will be there. So go to the snapshots, you can see automated snapshots and shared with me. Someone can share, some other account can share the snapshot with you, and whether you can see so many public snapshots. I don't recommend you to I don't recommend you to use this, because this will, we don't know what is there in that, so it may crash your system. Okay. So backup service, whatever is like kind of enabled and running, will be there. Okay, and you can also export all these backups to your S3 as well for your any feature. This one you can do. So that is on the snapshot. This is on the automated backup. Then you can reserve your instance, just like a reserved instance. You can reserve for your this one also. And there is something called proxies. So what are these proxies? In your company, you already would have heard of this called proxy. Let's see what is this proxy. So assume that you have your application, and your application talks to your database, right? So all the reads and writes happens directly to the database, and assume that there are application 1, application 10 applications trying to access your database. What will happen? Your database will take a very bad hit, and the performance might go down. So in order to reduce the stress and relieve the stress on database, we add something called proxy in between. So your application will always talk to the proxy. Your proxy will talk to DB. What will happen? All the contents, most of the frequently accessed contents will be cached in proxy, and your application reads the proxy. The application is faster. Whenever there is new update, the proxy will read the database and get it and give it back to the application and have a copy in this one, just like our edge location, right? So this is what it happens. This is your proxy. You can create proxies for your databases. After creating the database only, you can create the proxy, and you will give the proxy's IP URL or endpoint to your application, and that will talk to the proxy. This is what the proxies are. Okay, proxies. As I told you, these are the default subnet group that is created just now, just we upgrade. Or you can go and create your own DB subnet, right? So you create a subnet group in a private subnet group for you to just store only your database. Then we talked about the parameter group and option group. These are the parameter groups. So if you go and select for MySQL, right, for example, these are all the parameter group. Click on that. You go inside, you see different parameters and different values are there, and that will do different functionality. So your say auto commit, for example, is true, right? So you want to change this, there will be some implication of that, and your DBA should be knowing this in and out to fine tune your database. Similarly, there are some option groups. You can set up some options as well, right? This is for MariaDB. You can go and set up some options if you have some options. Then custom engine versions. These are all, if you want to create any custom engine version which is not there as part of the AWS, you can go and create and import those databases into this. If it is very old, something that it's not supported by AWS, you can bring it in inside here. Okay, this is on the this one. Next we have events. So what are all the events that is taken place in this particular database will be listed here. Then you can also subscribe to that event using a SNS topic. So whenever somebody creates a database, deletes a database, restarts the database, you will get notified. So those events can happen, right? So this is used mainly for event-driven architectures if you have, and that's the most widely used architecture. And it's always better, specifically for whenever the backup is not happening or backup has failed or something has happened, those events will be logged here, and you can subscribe to those events and you will get notified. Okay, and this is also nothing but your recommendations for your current thing. There is no any recommendation as of now. And certificate, the SSL updates you want to do, you can do it here. So these are all the options that we have for our databases. Let's click on this database, and now the database is available. Right now we have created our database. Since we have created the database for the first time, you can go and get the connection details. You can copy the password, admin name, password, whatever you have given, right? Everything will be there. Password will be visible only here once. After that, you cannot get this. So please remember your password, right? Now let's get inside and see what is there, right? So this is our database that we have given. So these are all some of the dashboards that we get. This is the engine that we have, and since we have created as an instance, it's an instance. It is created by default in US East 1D availability zone. It has created there. We did not specify any availability zone, so it created in US East 1D. It's a single database. Okay, it's a single database. So the first is connectivity and security. This is the endpoint that we need to use to connect from application or from outside, and this is the port number. Okay, availability zone is here. This is the VPC. This is a subnet group, and these are the subnets that it has created for this database. And network type is IPv4. It supports IPv4 only. Coming to security, you see here we just gave the name. It created a security group. Let's go open there and see what is happening, right? That security group. What is allowed? So go to the inbound rule, edit this inbound rule. See here, it has already put there. MySQL Aurora works in 3306, and it says by default only this port is open for this particular IP, which is my public IP that I have logged in now, right? So this is my IP. So only I will be able to log in. If you want to allow your only company's IP, then go and put the company's range 192.168 and put that range. We talked about all the CIDR ranges. Go and put your network company's network range. Only the people from your company will be able to access that. Right now, since we need to access, I just made it only for my this one. Okay. This is on your this one, and publicly accessible. It should be no always. I made it yes because I want to show how to connect to this database and make sure the database is created and we are able to do some operations. If we have a application already connected to this database, then you can work through the application, like submitting your first name, last name, and entering into the table and taking in all those things that you can do. Certificate authority, by default there is a CA created for RDS. It will use that. Certificate authority date, okay, it will expire on this one 2024. Since we created now, it will valid for 2 years. Of course, we are going to delete this database once it is done, but these are all the things that is available for. Coming to security group rules, there are no any rules. Replication, see, when creating a database, create one replication for you. Okay, one replication, so that it is highly available for you. Proxies, we don't have any proxies. If you want, you can create proxy and you can start using that. This is for MySQL. Give the name of the proxy and give all those fields. And what is the group configuration, database name? This is my database name. And what is the connections, connectivity? Give all those things and say create a proxy. It will create a proxy and give you a URL. Use that proxy URL instead of the direct database URL, right? So this is where you can go and see your proxy. Okay, so this is on your connectivity and security. Okay, fine. Coming back to the next tab, monitoring. So we did not set any monitoring as such, but you have a default monitoring from CloudWatch, which is available here. So you can directly go to this there, or you can just see a snapshot here, right? DB connections, free storage, write IOPS, read IOPS, input output per second, how much count, right? All those things. Okay, coming back to logs and events, you can see some of the events that is DB got created, DB got restarted. All these things are there. These are all the logs that we have, right? These are all the error logs and other things you can have. You can go and say view this log. You can see all these logs here, right? If you're able to make out something, that's good. So go to events and logs and select the appropriate logging that you want. This is this one, and go and say view is what showing, right? Upgrade, please start the MySQL binary. So it has done some this one. So that is what we have. Okay, fine. This is on your logs and events. Now if you go back to this events, see the same events here. So you can click on this event, for example, and you can go and see what is exactly happened in that event, right? You can go and see. This is on your logs and events. Configuration. This is where your database configuration is, right? This is my database ID, and this is my engine. My database name is MyDB. This is where I'll create my schemas and tables and everything. License model, okay, options group, then ARN, Amazon resource name for this particular database. If you want to refer this into some other services or roles, you need to use this. This is an internal resource ID, which is being referred for AWS purpose, which we will not be using anywhere. Okay, so when it was created, see, it takes the local time zone. Okay, you have local time zone. Parameter group, deletion correction is disabled. We have unchecked that box, so it is disabled. Now instance class, we selected DB T3 micro, which is a free tier eligible. It contains 2 CPU and 1 GB of RAM. Availability, master username, and what is authentication? DB authentication, IAM DB authentication we did not enable. We only enabled the username password. And then multi-AZ, no, we did not enable because that is disabled by default. We will see how to do this. If it is enabled, it will say you secondary zone where it is, right? Right now it is in 1D. It will show you where it is in the secondary zone. Storage, encryption is not enabled. Storage type is general purpose GP2. Provision IOPS we have don't have anything, and general purpose is 20 GB. Auto scaling is disabled for this, and performance insights has been turned off. And you can see the database activity stream is stopped. So nothing. There is no streaming of any data in this, right? So these are all the recommendations that you can say. Automated backups. They're asking you to enable this. These are the recommendations, right? Or the best practices. Maintenance and backup, whatever that we have given, we have actually disabled this. But if you enable those things, you can see all the pending maintenance backups and everything here, right? You can take a manual snapshot from here. And this last is the tags. There are optional tags that you can have. Okay, any questions here, guys? I mean, the entire page we have seen this. Now let's go back and see how we can connect this, right? So copy this endpoint. Copy this endpoint. Go download any client tool you want. I have this tool called SQL Electron. SQL Electron. It's called SQL Electron, but it's very difficult for me to pronounce that, so I always say SQL Electron. So it's called SQL Electron. It's a lightweight client tool which supports only few database engines, right? Okay, so let's go and add this connection. Give the name of this connection. So today is my 0813 MySQL. Okay, see, this particular tool supports only these engines: MySQL, PostgreSQL, Microsoft SQL, SQLite, and Cassandra. It does not support, this particular tool does not support Oracle. So you need to have Toad or some other client tool. So let's go and select the MySQL. If you would have enabled the SSL, you need to enable the SSL here and pass the SSL certificate there, right? That's the reason. Now host address is whatever that we copied. This is the endpoint which you will be using in your application as well as to connect to the database. This is by default 3306 only. We did not change the port, so that is fine. Now what is the username? We gave it as admin and give the password, that whatever password that you are using to connect, and what is the initial database that you want to connect, right? Go back to your management console here and you can come down to configuration and come down here and see this is your database name. So when you give this database name, it will automatically come with the database changed. Otherwise you need to change your database and use your queries, right? What is it? I think it is MyDB. Okay, MyDB. Fine. That is the initial this one that you can see this. Now let's go and do a test. See, this connection is successful. The reason is the security groups allows only from my IP to this port number. Since we made it as accessible publicly, I'm able to connect from here to there. So let's go save this and try to log into that and see what happens. I'm now trying to connect to the database. We are already in MyDB database, and you can go and create. If you know SQL, you can go and create. So let's go and create a table called EMP. Create a table name, and you need to give a correct me if I'm wrong, varchar 2 of 20. Okay. I hope this is correct. Let's go try to execute this. There is an error. Can someone say me what is that? Varchar 2 or varchar?
For table name, you will not define the variable, right?
No, we'll have to say, right, the columns in the table. What are the columns table? We need to say, right? Let's quickly don't worry. Right? We'll just go and find out. Okay. So even though I do this 1,000 times, I still keep forgetting for some reason or the other. Okay. So you have, right, create table varchar like this, right? So let's go and see if we can create some table. Okay, make it this one and name. Okay, it should be this bracket should be there. I think we missed that only. Okay, now go and execute. The query is successfully created. Now next thing that we need to do, you need to go and insert into EMP. Then here is where we need to give the values, right? Whatever we wanted to give. Okay, now you go and select this, select star from EMP. That is the only query that I remember always, select star from. Okay, you can see the name. So you can go and keep entering more names. So we have a couple of data there. Okay. Ashok, Suresh. I use these names very often. Suresh, Ganesh. It's very easy to say here in the rhyming format, right? Suresh, Ganesh. Okay, just for us to see some rows, right? Okay, so now you are able to connect to the database. You are able to create a schema. You are able to insert the values, and you are able to retrieve and see them, right? So this is what your database is now. Now let's go back and enable our multi-AZ. Okay, multi-AZ, I told you, right? We can go back and enable after we create our database. That's what I told. So let's go here and modify. Every time you modify, again it will stop and start the database, which will take 5 minutes or so. Then we will, while that is happening, we will go back and check our slides for the Aurora DB, and then we will come back, because we are not going to do any hands-on in Aurora DB. Just understand Aurora DB, that is more than sufficient. So nothing we are going to change here. Everything is same. I'm not going to change anything here. Here, multi-AZ, create a standby instance recommended for production usage, but I will show you how this happens, right? Because we went through this, so we need to know how this one happens, right? And how we can simulate the failure also, right? Rest everything is same, nothing has changed. Just go back down, 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 and say continue. Once you come here, it says the summary of modification. Current value is no, the new value is yes. It will ask whether you want to apply it immediately or you want to apply to the next scheduled maintenance window. The reason why it's asking this is because if you try to apply immediately, that sometimes the database might go down and come up, right? So that is why it's asking this question. Now, since it's just a test database, we know what we are doing. We are going to apply immediately, but in the real-time scenario, it should be in the next scheduled maintenance window only. Okay, that is why giving the maintenance window schedule is very, very important. Okay, that is why he's saying, see, there may be a performance impact if you do it immediately, because the DB might go down and come up, right? Do a modified DB. Let's go back and see. Just refresh here. What will happen once it is refreshed? It will start modifying your database. Okay, just give it a minute. Okay, it now got changed. Okay, see, it's changing now. Modifying, this will take few minutes. Let it take. Let's go back and just check on our Aurora and come back. Okay. Okay, let's talk about Amazon Aurora. Aurora is a proprietary technology from AWS. It's not open sourced, so it is only available from AWS. And currently, the Postgres and MySQL engines are supported by Aurora DB. So all your Aurora is cloud optimized, and all your queries will work similar to your MySQL or Postgres, depending upon the type of engine that you select. Postgres and MySQL are supported Aurora DB. That means your drivers will work as if Aurora was a Postgres or a MySQL database. So Aurora is AWS cloud optimized. So since it is cloud optimized, they claim that they have five times more performance improvement over normal MySQL or RDS. So we have created RDS. If we would have created Aurora with MySQL, we would have got 5 times more performance than the RDS and 3 times performance of Postgres. Very important is Aurora storage automatically grows in increments of 10 GB. So auto scaling you need not enable, it is automatic. Aurora storage automatically grows in the increments of 10 GB up to 64 TB. So you need not worry about your storage. Aurora can have 15 read replicas, while MySQL can have only 5. And the replication is very, very faster. It is sub 10 milliseconds replica lag. So when I told you, when we do the read replica, you have an asynchronous way of replicating, right? That's what I told you in read replica. It will take some seconds, but here in Aurora, it basically does in sub 10 milliseconds replica lag. That means it's very, very fast. Failover in Aurora is instantaneous. So something happens automatically, it will fail over. It is highly available in native. Aurora costs more than RDS, 20% more, but it's more efficient also. Okay, so just keep that in mind. Where you want your database to be fast and all those things, you should go for Aurora. But again, Aurora is highly costly, and you need to make sure, depending upon the client's requirement, you can go for this. So Aurora's high availability and read scaling, they have 6 copies of your data across 3 availability zones, 4 copies out of 6 needed for writes, 3 copies out of 6 needed for reads, and you have a self-healing with peer-to-peer replication. If one of the read replica goes down, automatically another read replica will come up and it will kind of self-heal by itself. You need not do anything. The storage is stripped across thousands, hundreds of volumes. That means what is happening? It's a network storage. So that is why when you are writing something, it immediately gets replicated to everywhere because it is a shared storage volume. One Aurora instance take writes. So we have, when you create a cluster, one will be the master and rest everything will be the reader endpoints. Automated failover for master in less than 30 seconds. Okay, right now when we are going to do a failover, manual failover, it will take 5 minutes. This will be like 30 seconds. Master plus up to 5 Aurora read replicas you can serve for reads. So master also will serve for read and you have 15 more read replicas. It supports for cross-region replication as well. So replication can happen in cross-region also. So this is how it happens, right? We have one master database and we have 15 read replicas, and this is the shared storage volumes. It automatically replicates itself, self-healing, auto-expanding, everything is there. So which means kind of it's totally automated for you, but you need to pay that price, and for that price, the performance was great for this. This is how you, when you create a Aurora bathroom. So when you create Aurora DB cluster, then you get a writer endpoint separately and reader endpoint separately. So you get one reader endpoint that is load balanced between these 15 read replicas. So if you just update your reader endpoint, it will redirect to any of these 15 read replicas. So one writer endpoint always pointing to the master. Okay. If we have time, we will go just see if we can just see what is there. Some of the features of Aurora, we have automatic failover, backup, everything, or rest everything is same. Backup recovery is there, isolation and security, all industry compliances are there. Push button scaling, you enable a checkbox, it will scale. Automated patching with zero downtime. This is very, very important, right? With zero downtime. So what will happen when this master is getting patched? By default, one of the reader will become a master and this will get patched. Okay, when this is getting patched, this will get the load and this will get patched. So there is no downtime at all. Advanced monitoring is there, routine maintenance is there, backtrack is there. So restore data to at any point of time without using backup. There are no backup, right? The backups are done automatically for you. There is no way that you can go and say you restored from a backup, right? You simply say, I want to restore data from yesterday 7 p.m. It will only restore the data from 7 p.m. So you can have a backtrack. You can backtrack till the time that you wanted to have the data. Encryption is the same, nothing different. We can use encryption at rest using KMS, automated backup snapshots, replicas, everything is encrypted for you. Encryption in flight using SSL, same check, MySQL and Postgres where you need to set up those flags. Authentication is using IAM. You can also use username, password. You are responsible for protecting the instance with security group. Yes, of course, we need to have the tight security group, and you cannot SSH into Aurora DB cluster because it's a managed service. This is a normal Aurora, and they have something called Aurora serverless. Now, Aurora serverless is like you don't have to select your instance type, nothing. It is a serverless architecture, and you can use this Aurora. No need to choose any instance size. It only supports MySQL and Postgres. I have to update this slide. I have to see currently what it is supporting, but of course it supports MySQL. Which version is not version alone we need to update. Postgres. Helpful when you cannot predict your workload, right? You don't have any way your customer doesn't know what is happening. You can try to put it here. DB cluster starts, shutdowns, and scales automatically based upon your CPU connections. If CPU connections are going more, automatically it will scale out and scale in. You have an option to migrate from Aurora cluster to Aurora serverless and vice versa. But only thing is, some of the features in Aurora still are not supported by Aurora serverless. So you need to check the documentation. if in case you want to convert from Aurora to Aurora serverless. Okay, how this usage is measured in Aurora serverless? Because if you see in Aurora, the billing will happen based upon your instance type, right? If I have a M3 large instance, I pay for that. But here what happens? It is all measured using Aurora capacity units. That's called ACU, Aurora capacity units. It's built in 5 minutes increment of ACU. Okay, so based on this ACU, they will bill you your Aurora serverless. Okay, let's come back to this ElastiCache once we just do that, and we will be done with the RDS. Okay, let's go back to our RDS here. Just refresh here and see if it is still available or still modified. I told you, right, this will take some 5 to 8 minutes. Okay, so whereas when you are doing this in Aurora, all these are faster. Now it is available. So what has happened? It has enabled your multi-AZ thing, right? Let's go down and see. We'll go down. See here, multi-AZ has been enabled now. Okay, now how do we test this? Go to actions and try to reboot this machine. When you are trying to reboot the machine, it will ask you, we are trying to create the failover now. Do you want to failover, reboot with failover? That means what will happen? Now if I say yes, what's going to happen? Now when I'm trying to access this data, it is going to fail over to this, and as I told you, it's a synchronous application. All data will be copied here. Already they're ready for you. Let's go and prove that, right? And there will be some downtime for few minutes, right? That also I told you. Let's see if we are able to prove that, right? So let's go and reboot with the failover. So it will reboot to the standby. Just confirm this, right? Again, it is rebooting now. Now go back to this one and keep executing this. At one point in time, when it is trying to reboot, it will lose the connection. That means it is now switching from your master to the standby, right? That is why it is switching. We already have this data in our, so now see, we are not able to connect because it's already rebooting now. So it's now trying to go into the standby. Let's wait for this one to come up. Let's see. Okay. So just like proxies, we have something called ElastiCache. Okay, let's talk about the ElastiCache also, and we should be done. Okay. So ElastiCache is to get rid of, before, even after the proxies, you can have this ElastiCache. ElastiCache will actually is a service which will cache all your database related queries and keep it there, and then your application can access the ElastiCache, and you can also store all your user session data as well in your ElastiCache. So ElastiCache is to get managed Redis or Memcached are the two products that uses this ElastiCache. Caches are in-memory databases with really high performance and low latency. It helps you to reduce load on the database for read-intensive workloads. Helps make your application stateless also, right? It uses right scaling using something called sharding. Sharding is nothing but like it will create small nodes. Read scaling using read replicas. You can use a read replica, create a read replica for ElastiCache also, and you can also have a multi-AZ with automatic failover capability. AWS is a managed service, so AWS will take care of all maintenance, patching, setup, configuration, everything is taken care by your AWS. So application queries your ElastiCache first. If it is not available, it will get from the RDS and then it will store the copy in ElastiCache. It helps relieve load in your RDS. Cache must have invalidation strategy to make sure that only the most current data is used in the cache, right? So you need to have some kind of invalidation strategy. We talked about shard. A shard is nothing but collection of one or more nodes in an ElastiCache cluster. It is created to support replication of data into various nodes so that your cache remains reachable in case of loss of few nodes. So you have 5 nodes. If 2 nodes are going down, still your data will be available in the other 3 nodes. So this is how it happens, right? You have your Amazon ElastiCache between your database and the application. So your application, whenever it wants to read the database, first it will come to Amazon ElastiCache. If it finds a cache, if it finds the data there, it's called cache hit. It's called cache hit. If it doesn't find the data, it is called cache miss. Whenever there is a cache miss, it will go to the database, read the data from the database, come back and give it to the customer and write a copy to the cache. Next time when somebody accesses the same data, it will be a cache hit. So this is a cache miss, this is a cache hit. What you are trying to do? You are trying to relieve the pressure of your RDS, so by putting some proxies and ElastiCaches here. There are two products, and you can also store your user session store data there. So user logs into any of your application write your session data into ElastiCache, and the user hits another instance of your application. The instance retrieves the data from the ElastiCache that they are already logged in. They need not log in again and again, right? So this is what they can do. Whenever user first logs into the one user logs into the application, it will write the session data for him. So all his login information will be here. And suppose he refreshes, he will still be able to be inside the this one. If you don't write any session here, what will happen? Every time you refresh, you need to log into the application. So this can be used to store your user session store as well. Now here, so you have two products for your ElastiCache. One is Redis, another is a Memcache D. So Redis is an in-memory key value store. It's a super low latency, and you can use this. Very important, it is a persistent in-memory store database, so it can survive any cache can survive any reboots. So it's great to host user sessions, leaderboards for gaming. You know what is a leaderboard? So when you do an online gaming, you can see you have a leader. Okay, I'll be playing some game. My name will go to second. It will come to sixth. It will come to fifth. That's called leaderboard, right? So that's a leaderboard. So you can use that for leaderboarding. You can use for distributed states. You can relieve pressure on your database, and it works on the publisher subscriber model, and you can use that. You can subscribe to get some notifications as well. Multi-AZ with automatic failover for disaster recovery if you don't want to lose any data over on your cache. It's support for read replica. It has support for read replica. Whereas your Memcache D is a memory object store. Cache does not survive reboots. It's just equals. Assume just to for an example, your Redis might be equal to your EBS, whereas your Memcache D is equal to your instant store volume, which is an ephemeral storage, right? So Memcache D is an in-memory object store. Cache does not survive reboots. Use cases: quick retrieval of objects from memory. Wherever you want, you can use that. But cache often access to objects. Overall, Redis has been used widely in our organizations, and it is grown in better popularity. So Redis is not the product of AWS. Redis is a separate product, and AWS supports Redis. Okay, so it has better feature sets than Memcache. This is what we have for our RDS. Quickly jump here, see if you can execute now. See, we are able to execute now, and you can see it's now actually pointing to standby. We don't know, since we don't know, right? As I told you, whether it is pointing to standby or not, we don't know, because we cannot access the standby directly. But we know we did manually fail over to the standby, and if you go inside this, the connection string is still the same. We did not change anything for the connection string. Here we are able to now access this one. Now if you go and try to again reboot, then it will ask you whether you want to do a failover again. Now what will happen when you do? It might move from standby to your master database. Very important thing, when you create this, there will be a cost associated for the data transfer through network. Okay, just keep that in mind. So this is on your RDS, right? So quickly we'll just, you're not going to create it, we'll just try to see if we can just go ahead and see regarding your how this Aurora looks like, right? So that's a proprietary database. Let's go and see what are the options we have. Aurora, as I told you, it supports only MySQL and PostgreSQL, and You can go to replication feature, whether you want a single master or a multi-master. You can have multi-master also. When you select single master, you get a single master and you get 15 read replicas if you create a read replicas. Okay, so Aurora MySQL, this one template, whether it is a production or dev test, there is no free tier. See here, there is no free tier. So we will have to pay some cost here. Again, this is the name of the database, credentials to connect, same just like your SQL. Nothing is different, right? So memory optimized class availability, create an Aurora replica or reader node in different availability zone recommended for scaled availability, or don't create any replica. Okay, you can go and select it here. And see, nothing else we selected, no backups, no restore, no maintenance, nothing, everything is automatic for you. Go ahead and create this, then you will get two different endpoints. One is the writer endpoint and the reader endpoint. Okay, this is how your Aurora works. Okay, so with this we come to the end of your RDS. So just you need to know what is RDS service, how to do this, and we have just connected directly from here. The best option is to always have some application written, and through the application you need to connect to your database from the private zone. Okay, just keep that in mind. Any questions you guys have? Just let me know. For free tier, you will not get read replica, so that is why we are disabled. If you are having a paid one, you will get a read replica. Okay. Once you are done with this, please make sure you delete your database. Okay, you have to delete your database. Before deleting, it will ask you to take a final snapshot. Of course, there is nothing there. It's only this one that we have. Nothing else is there. So we are going to kind of not take any backup, but in the real-time scenario, it will prompt you to take this one. And you need to say you acknowledge that upon instance deletion, automated backups, including system snapshots and point in time recovery, will no longer be available. Yes, I am aware. To confirm the deletion, click on here and say delete me. And this is the recommendation given by AWS, saying we strongly recommend taking a final snapshot before instance deletion, since after your instance is deleted, automated backups will no longer be available. Okay, so this is just to kind of make sure that you are aware of this. Click on delete. Again, just like our creation, deletion will also take some time, but please make sure your RDS is deleted. If it is not, it will incur some charge. Okay, while that is coming up, while that is happening, let's go quickly. Just give a sneak peek into your backups, and just make sure that there are no any backups created, even if you would have enabled by mistake, right? Just make sure nothing is there. Okay, so this is what your databases are. Any questions that you guys have? Please let me know while this is deleting. So how you will do this, right? How you will actually do this, right? With all the services that we have learned so far, what you can do, you can create an EC2. You know how to create an EC2. Create an EC2. Then install your Apache, and then install some application like PHP applications, or some application which will simply have a form to take the first name. When you submit, it has to get into the database, right? So this can be your use case. This can be your use case. It's a full use case. You can do this. And if you want to go one step further, what you can do, you can create two EC2 machines. Okay, two EC2 machines, E1 and E2, right? And place them before the load balancer. Place them before the load balancer. So whenever you hit your load balancer, then that is where you're okay. Place it before your load balancer, and whenever you hit the load balancer, then it will go to either E1 or E2. Make sure both E1 and E2 runs the same application, same PHP pages, and it connects to the same DB. Okay, that way you will be doing the full-blown project. Okay, for that you need to do this. Okay, So if you don't know PHP or you know Python, whatever language you want, you can choose. But if you want, you can simply go and check the net to get some pages on how to get this some PHP, right? You can go and check on Google and get some projects from there. Go to Google and just say PHP code to connect to MySQL database, right? Go here and go here, and you will see how to connect to your database. So you need to write this into your PHP, and whenever you hit the submit button, you need to call this, and you can create, you can insert the, you can create the table, you can insert the data using this query, right? You can have the server name. Server name cannot be localhost, it should be the endpoint, your username, password, your DB name, give the connection and insert into that emp table your first name, and then just do this, it will get into your query. Now how do I go and read this table, right? You can go to a select data and you can go and read this, and it will come out, and what you can do, you can write that as an HTML page. So how it will look like, it's like this, right? Your page might look like this. When you get into that PHP first page, it will say enter your name. This is a label. Okay, enter your name is a label, and next to the label you will have a text box where the people will enter and say submit. When they hit submit button, you will what you will do, you will go and insert it into the database, and when you are loading this page, you will read from the database and say names in the database, and put one table here with all your first names line, right? You put and read it from the database whenever this page loads. So in one page you will see both the things, right? So that's what you can check. Okay, so these are all something you need to try it out on your own. Okay, and I've just pointed out to you how to do that, and try out that, and if you guys have any queries, let me know, then we will see why it is not working, right? I have some test pages, I believe, and let me quickly check. Just give me a minute. PHP, right? Test PHP. I don't know. I think I showed to some people earlier. I might have somewhere, I don't know. But anyway, the idea is that so you guys can go and create those things. This is the PHP installation of PHP. Okay. Now where is my code? I don't know if my code is there. Let's go and check for PHP, Python. Some Python is there. We like to work with Python more than PHP. So I'm just giving you an example. So it can be any way that you can create this. If you are familiar with Java, go ahead and write in Java, right? It's up to you. Somewhere I got this code, I don't know, but somewhere it should be there. Okay, so guys can check on that, and you can create your own PHP pages, and you can go ahead and do this. Okay. Okay. Any other questions that you guys have? Just let me know if you need any questions or anything. And just to let you know, like tomorrow we will not be having the class. I'm actually traveling to my hometown, and we will next meet only on 28th. Okay, 28th. is where we will meet. I'm off for a week because it's a long weekend, and we will be meeting next week. Okay, so please go ahead and try this. Try to work on this one and see if you are able to kind of do something about it, right? So that you can practice all those 6 or 7 services that we have seen so far. Okay, any other questions that you guys have? Just let me know. Just give me 1 minute. Try to get that code for you guys, right? Here is, I believe. That's all. No, they are not. I actually created something for some project, right? Okay. The last place we will check this. If not, then we will. I don't think we have. So the idea is just to make sure that you guys can connect to this one and how you want to run your PHP in your EC2, run it in your EC2 and see if you are able to connect to this one. And always keep that your database in private so that you will be able to access your database from your application, not from this kind of tool that we are talking about, right? So just keep that in mind. Okay. Any other questions that you guys have? Okay. All right, guys. So thanks for your time. And once this recording is available, I will upload and keep you guys posted. And tomorrow we will not be having the class. I will just put the message in our group as well, and we will meet next week. Okay. Thank you, everyone. Thank you.